Hello everyone, my name is Zaman Ali. I am along with my friend Muhammad Riaz Ali, and we have taken this project under the supervision of Sir Dr. Engineer Gulsher Ali Baloch. So our project is about IoT based healthcare beds for monitoring of sleep pattern systems of SCI patients. SCI stands for spinal cord injury patients. These are the table of contents that we will be discussing in our project. Introduction, motivation, problem statement, the literature review, aims and objectives, methodology, results, conclusion, and the future work. So first of all, coming towards the introduction, smart medical beds are integrated solutions for patient care on the basis of their multidisciplinary approach and the research fields. They also provide accessible solutions and opportunities. Along with that, smart beds also provide us efficient efforts for caregivers and the responsive environment for the people who are actually sick. Now, our system is dedicated to the monitoring of bed patterns of SCI patients, the spinal cord injury patients. In today's world, more people are appearing to have a problem related to spine, and such patients are being kept in complete monitoring through analyzing their bed patterns and postures. Before curing, they are required to, they have to give their postures, sleeping patterns. Our system is IoT based healthcare bed. Now our system is totally dependent on IoT components, the force sensing resistors, microcontrollers, app interfaces, and the PCB designs and other hardwares. Monitor the bed patterns and postures of patient will create its direct communication to the doctor or the concerned caregivers by prevailing them the result. Now the motivation, what actually motivated us to do the work on this project. There were two motivations. The first motivation was to replicate the Korean bed. Now actually this project is already implemented in the Korea. So the patients were, actually their problem was to intend the assist, monitor the elderly patients for problems of bed sores. And the second motivation is to provide IoT-based solution for doctors to diagnose their patient remotely or any patient trying to get himself diagnosed from any doctor remotely. The problem statement, actually problem is about the spinal cord injury. Any place rapidly in both youth and elderly people. In most of the accidents are in mishap. People get prey in for this disease such as carrying heavy equipment, road accidents, sudden stretching or spine or any force damaging. It can lead to spinal cord injury. There can be any problem, lifting of loads, road accidents or other any mishap. Sometimes these injuries can occur due to posture while sitting or lying on the bed. For example, we sit on tables or sit on chairs while working in offices. We don't care about the postures, how actually we are sitting. Actually, our seating arrangement is proper or not. So, spinal cord injury can also happen due to improper seating arrangement. Those prolonged habits may result in spinal cord injuries, and to avoid such injuries or for the treatment, patient need to be kept under monitoring in order to analyze their bed patterns, which require efforts to doctors, nurses, and caregivers. Actually, those people are kept under the consideration and they are monitored every time. So the literature review. We have studied many research papers and articles related to our project. So these are some literature reviews. The first paper is about the field of smart bed. Actually, the prototype, which is the best and and present in the market. This paper we are given with the insight of state of art in the field of smart beds. This bed includes everything from displaying vital of the patient to the controlling of position of beds. Now the second paper is about the Pakistani peoples. When Pakistan was hit by the earthquake 2005, this paper was developed after that in 2017, when the SCI patients in Pakistan and their rise after 2005 earthquake and its major effects. Third paper, in this paper we are provided with the insight of use and necessity of the bed sensors. This paper explain how bed sensors got attention in 2008 and its future use in assisting elderly patients living alone. So literature review still continues. There were actually two systems which are best working nowadays. So the next system is also Korean bed system monitor to sleep quality based on several sleep parameters. It uses triaxial accelerometer to monitor the sleeping quality. And the second project was Korean based system for elderly patient based on problem of bed sores. These were two best papers that we found in relation to Korean bed. This is the comprehensive analysis of literature review, our system and the other systems that are already implemented in Korea. This is some analysis. The problem statement, our problem statement was to monitor the bed patterns and postures to avoid spinal cord and disorders. The Korean bed has the problem statement to monitor the time, sleeping time, and patients to avoid bed sores and alerting for fall accidents. The third paper has the problem statement monitors sleep quality based on the certain sleep health parameters. Now components used in our project are FSR 402 4 sensors, Node MCU, 16-channel multiplexer, self-designed PCB. And for the smart bed used by Koreans, they used 406 and 408 FSR sensors along with microcontrollers, Raspberry Pi, and load cells. And the third paper, they also used, this is also Korean, so in triaxial accelerometer. So they used load cells, acceleration sensor, pressure sensors to monitor the sleep, quality sleep. Now cost is dependent on the components. So we used not that much components. We used FSR 402, Node MCU, multiplexer, and PCBs. So our project is not that much costly as compared to both other projects. Application, our project is purpose specific, and the other are triaxial accelerometer project is multi-purpose, and elderly patients with impaired mobility is also a specific purpose. Now the aims and objectives of our project. Aim is to monitor the bed pattern of the patients. Once we monitor the data and found the data through sensors, we have to transfer it and receive data to doctors and caregivers. Design of the system to help doctor to monitor the patient bed patterns in more convenient way. The methodology. This is the whole flow chart of the project actually that we designed. First of all, we designed PCB, then we placed sensors, and then designing complete prototype, and then algorithm at which the system would be working, the programming of prototype, Node MCU, Arduino IDE, and then we transfer data to IoT ThinkSpeak and the Telegram bot, and then sending data to app, and then analyzing the results. Now the results will be analyzed by doctor because this whole system is dependent on the data, and data is monitored by doctor. So the data transferring among node MCU, ThinkSpeak and Telegram bot and app. This is how the data will be transferred. Actually, sensors will detect the pressure and convert it into data, and it will be transferred to multiplexer. Multiplexer will transfer it to serially transfer it to node MCU, and then node MCU will transfer it data to both ThinkSpeak and Telegram bot simultaneously. And the data on ThinkSpeak will be transferred to at last application, which is installed on the mobile. Now sensors and the controller that we use in our project. Node MCU, we have used Node MCU, which is actually the development board especially targeted for IoT based applications, which include the ESP and Wi-Fi module. And it has ESP12 module. We have used FSR 402 sensors. Actually, the best prototype that we were following was the Korean, and they had used FSR 406 and 408 sensors. Because of the unavailability of the sensors, we could not use those sensors. So we have used FSR 402. Obviously, these sensors are less accurate as compared to other host sensors, but again, these sensors have also good data rate. They convert the resistance in ohm. They basically detect the data, pressure, and convert into ohms. And these sensors are fairly low cost and easy to use, but they are rarely accurate. They are not accurate as much as 406 or 408 sensors. Now the system design. We have used these some components in our as a software in our project. MIT App Inventor, we have generated the application using MIT App Inventor. And also we have used the Arduino IDE for programming the device, and ThinkSpeak for converting the data and getting the data from Node MCU, and then Telegram bot. Now coming towards the results, this is the self-generated PCB board. Actually, we have designed two types of PCBs. This is PCB for connecting the node MCU and multiplexer along with the sensors. And there is also another type of PCB, which is SMAL. And this SMAL PCBs are actually, we designed 6 pieces of same SMAL PCB. So that we can connect each 4 sensors with single PCB board. So these 4 sensors are connected to one PCB. The other 4 are connected to second PCB. Third are with third PCB, and fourth are with fourth PCB. And all these at last are connecting towards the main major PCB, which is connected to node MCU. This is how the app layout is. We have generated app using MIT App Inventor, and data, when the pressure will be applied on the sensors, any load will be placed, the patterns will be generated, and these LEDs will be illuminated after the pressure detection. Once the bed was pressurized, the pressure detected at different sensors will be highlighted here. For example, the pressure at the upper area of the body will be detected at first 4 sensors, and the last 4 area will be detected at last 4 sensors. So this is how the patterns are generating, and we have concluded this as a pressure sensing. Simultaneously, the data will be transferred to the application, Telegram application and mobile. The messages will be generated. The pressure that will be detected on the application will be sent to mobile application as messages. The practical pressure on the thoracic region. Now actually these are 4 regions of spinal cord. Spinal cord is divided in 4 regions. Lumbar region, thoracic region, and which region will be activated, the pressure will be detected, and these messages will be generated according to the region of spinal cord. So coming towards the conclusion and the future work. Conclusion: design work successfully on the purpose. It was designed for the bed system and design in a way that it can be placed on any bed, whether bed placed at a hospital, home, or anywhere patient bed patrons can be easily monitored by certain physiotherapists, doctor, or caregivers. One we have designed actually prototype. It can be placed at a hospital or it can be placed at home or even any place, and data can be monitored by physiotherapist, doctor, or caregivers. As it is IoT based healthcare bed system, so the patrons can be analyzed remotely in effective manner. Conclusion and future work. For future work, it can be made more efficient and effective using the processing. Obviously, when we replace the sensors, FSR 402 sensors with latest sensors, then its efficiency will also increase. If we remove Node MCU with 12-bit ESP with some other advanced type of microcontroller in future, it will also enhance the capability of our project too. So this is for future recommendations. These are the references that we have from which we have taken the material of our project. And that's all. Follow us and thank you.